Hey folks, welcome to lesson 2.3, deductive reasoning. Before we go there though, let's do a quick bell work, some review from 1.5, 1.6, and 1.8. You might want to pause it now, see how you do, and come back. A, if the measure of RVS is 3x and the measure of angle SVY is 6x, find the value of x. Well, here's angle RVS. And here's angle SVY. So you see if you put these two angles together, you've got a set of supplementary angles. In fact, you have a linear pair. So how are we going to calculate x? Well, you're going to set 3x plus 6x equal to 180. That means that 9x is equal to 180, or x is equal to 20. All right, next, we are told, B, that if the measure of angle WXV equals 10y, find the value of y so that segment WX is perpendicular to segment XV. All right, well, if these two segments are perpendicular, then we know that this angle right here is a right angle, which is 90 degrees. Therefore, we can straight say that 10y is going to equal 90, or y is going to equal 9. All right, next. If the measure of RVW is equal to 5x plus 15 and the measure of angle TVY is 10x, find the value of x. Let's see, RVW and TVY are what we call vertical angles. They are vertical angles. This angle and this angle are vertical angles, which makes them congruent. Therefore, we can say that 5x plus 15 must equal 10x. Right? Congruent angles of equal measures. Therefore, we can say 15 is equal to 5x, or x equals 3. All right. Next, we have the perimeter and the area of a rectangle. Well, let's see. Perimeter of a rectangle is going to be 2 lengths plus 2 widths. The area of a rectangle is going to be given by length times width. These are called math facts, folks, and you memorize them. And I revise memorizing them earlier rather than later. The perimeter and area of a circle. Okay, the perimeter of a circle we call a circumference. That's 2 pi r. The area of a circle is pi times the radius squared. All right. Those formulas you can find in 1.6. Next, surface area and volume of a prism. Well, any prism is going to have the surface area PH plus 2B, and the volume is going to be given by BH. Okay, what's important here is you must know what these symbols mean, right? This first thing says surface area equals pH plus 2b. P is the perimeter of the base, H is the height, and B is the area of the base. Okay, volume is BH. That's the area of the base times the height. Just as important as memorizing these formulas are memorizing what they mean. the surface area and volume of a cylinder. Okay, surface area of a cylinder is going to be 2 pi RH plus 2 pi r squared. The volume is going to be pi r squared h. Okay, once again, what's important here is knowing that r means radius and h means height. I would urge you, folks, to understand why these formulas make sense, because they're a lot easier to memorize. For example, the volume of a cylinder. Pi r squared is the area of the circular base. H is the height. So if I multiply the two, it sweeps out the entire volume of the cylinder. That makes intuitive sense. Likewise, the surface area, 2 pi RH. 2 pi r is the it's the diameter of a circle. And if you multiply that times a certain amount of height, so say diameter circle times a certain amount of height, it'll sweep out all that outer surface area, like that of a toilet paper roll. And then 2 pi r squared is the area of the circle of the base and the area of the circle of the other base. Now you've got all the surface area. All right. Well, let's get into our lesson, shall we? Chapter 2, Lesson 3, Deductive Reasoning. Unlike inductive reasoning, which uses a pattern of examples or observations to make a conjecture, deductive reasoning uses facts, rules, definitions, or properties to reach logical conclusions from given statements. All right. Determine whether each conclusion is based on inductive or deductive reasoning. Every time Lauren has a healthy meal before her run, she is able to run farther than her sister, who does not like healthy foods. Lauren has eaten a healthy meal, so she concludes that she will run faster than her sister. Is this induction or deduction? This is inductive reasoning. She's basing her conclusion on a pattern of observations. Remember inductive reasoning? You look for a pattern and you make a conjecture which seems reasonable, which may or may not be true. That's what she's doing. This is inductive reasoning. If John is late making his car insurance payment, he will be assessed a late fee of $50. John's payment is late this month, so he concludes that he will be assessed a late fee of $50. Is this induction or deduction? This is deductive reasoning. He is basing his conclusion on a contractual fact. It's not up for debate. It's not a prediction he's making based on examples or experiences. He knows that in his contract it says if he's late in a payment, he owes $50. It depends on the fact. This is deductive reasoning. Why don't you try this on your own and then come back? All of the signature items on the restaurant's menu shown are noted with a special symbol. Kevin ordered a menu item that has this symbol next to it. So he concludes that the menu item he has ordered is a signature item. All right, inductive or deductive reasoning? Deductive reasoning. With this caveat, he is basing his conclusion on a definition, but only if there is a key on the menu that says the special symbol means signature item. You've seen this. You look at the back of the menu or the bottom of the menu and it says this symbol means special item. In that case, if you see the symbol, it's a special item. Try again on your own. Every time Raul goes to the restaurant on a Thursday, Cheese Supreme is the special. Raul goes to the restaurant on a Thursday, so he concludes that Cheese Supreme will be the special. What do you think? Inductive reasoning. He is basing his conclusion on a pattern of observations. Can't be sure. He may not even go every Thursday. This is just his observation, so he made a reasonable conclusion. Inductive reasoning. Inductive reasoning cannot prove a conjecture. However, one counterexample can disprove a conjecture created by inductive reasoning. Deductive reasoning can prove a conjecture. However, you must use a valid form of deductive reasoning. One valid form of deductive reasoning is the law of detachment. Let's step back. Inductive reasoning. Bunch of examples. Come to a reasonable conclusion. Maybe true, maybe false, hopefully true. Can't prove it's true. Deductive reasoning, you start with some facts or definitions or statements that you know to be true. From there, you can determine other things to be true. That's deductive reasoning. And there are many types of deductive reasoning. One of the valid forms you're going to learn today is called the law of detachment. The law of detachment, if P then Q is true, and P is true, then Q is true. Let's look at that again. If P implies Q is true, and P is true, then Q is necessarily true. That's the law of deduction. If the givens are true, the conclusion is true. For example, if a car is out of gas, then it will not start. If that's true, and Sarah's car is out of gas, if that's true, then necessarily Sarah's car will not start. That will be true as well. Determine whether each conclusion is valid based on the given information. If not, write invalid. Explain your reasoning. If two angles form a linear pair, then their non-common sides are opposite rays. Angle AED and angle AEB form a linear pair. Conclusion, ray ED and ray EB are opposite rays. Okay, you're supposed to determine whether each conclusion is valid based on the given information. If not, write invalid and explain your reasoning. So what do you think? Valid or invalid use of the law of detachment? This is a valid use of the law of detachment. If P, then Q. If two angles form a linear pair, then their non-common sides are opposite rays. Angle AED and angle AEB form a linear pair. Therefore, ray ED and ray EB are opposite rays. If you're having trouble with the language, let's revisit it. Two angles form a linear pair. Okay, this angle and this angle right here together form a linear pair. They are supplementary angles, and they are adjacent to each other. They have a common side. All right. So angle BEA and AED are supplementary, and they have the common side AE. Therefore, they're a linear pair. If two angles form a linear pair, then their non-common sides are opposite rays. This is the non-common side right here, and the other non-common side right here. The common side would be AE, or EA. All right. If two angles form a linear pair, then their non-common sides are opposite rays. Well, that seems to be true. Angle AED and angle AEB form a linear pair. Yep, AED and AEB do form a linear pair. Therefore, ray ED and ray EB will be opposite rays. This is perfect use of the law of detachment. If Mika goes to the beach, she will wear sunscreen. Mika is wearing sunscreen. Conclusion, Mika is at the beach. Okay. The given stuff we have to assume to be true. And the question is, does the conclusion necessarily follow from the givens. What do you think? Valid or invalid reasoning? Invalid reasoning. If P, then Q, if that's true, and if Q is true, then we can know that P is true, but we cannot know anything about P. If P, then Q is true. If Mika goes to the beach, she will wear sunscreen. Q is true. Mika's wearing sunscreen, but I cannot know anything about P from that. If 3 points are non-collinear, they determine a plane. Points A, B, and C lie in a plane. Conclusion? Points A, B, and C are non-collinear. What do you think? Is that valid or invalid logic? Does that follow the law of detachment? No, that's invalid reasoning using the law of detachment. If 3 points are non-collinear, then they determine a plane. If P, then Q is true. Points A, B, and C line on the plane G. What is that? P or Q? It's R. It's something totally different. It's neither the first nor the second statements. What conclusion can we draw? Nothing. We cannot conclude anything about P from the information given, not by the law of detachment. If a student turns in a permission slip, then the student can go on the field trip. Felipe turned in a permission slip. Conclusion, Felipe can go on the field trip. Valid or invalid reasoning? Valid. If P, then Q is true. P is true, therefore Q is necessarily true. Law of detachment. All right, the law of syllogism is another valid form of deductive reasoning. This law allows you to draw conclusions from 2 true conditional statements when the conclusion of one statement is the hypothesis of the other. So they have the law of detachment and the law of syllogism. Both are valid methods of deductive reasoning. Law of syllogism. If P then Q, and if Q then R are true, then if P then R is true. If P then Q is true, and if Q then R is true, then necessarily if P then R is true. Right? P implies Q, Q implies R, therefore P implies R. Makes sense. That's the law of syllogism. An example would be if you get a job, then you will earn money. Assume that's true. If you earn money, then you'll buy a car. Assume that's true. Therefore, necessarily, if you get a job, then you will buy a car. That'll be true. Determine whether the statement is valid based on the information. If not, write invalid and explain your reasoning. If you are an actor, then you enjoy musicals. If you enjoy musicals, then you enjoy theater production. All right, conclusion. If you enjoy musicals, then you are an actor. What do you think? Does that conclusion follow from the givens? No, that's invalid reasoning using the law of syllogism. 1 says if P then Q. 2 says if Q then R. We cannot determine this to be true if Q then P, which is what the conclusion is saying. That's gobbledygook. If you are an actor, then you enjoy musicals. If you enjoy musicals, then you enjoy theater production. That's your givens. Conclusion, if you're an actor, then you enjoy theater production. What do we say? Is this valid or invalid reasoning? Valid reasoning using the law of syllogism. 1, if P then Q is true. 2, if Q then R is true. The conclusion A, if P then R is true. That's perfect logic. If you do not get enough sleep, then you'll be tired. If you are tired, then you will not do well on the test. That's given. Conclusion, if you are tired, then you will not get enough sleep. Valid or invalid conclusion from what's given? Invalid reasoning. You're given if P then Q. You're given if Q then R. You can't talk about anything to do with if Q then P. You can't determine the truth value of that statement, not from the law of syllogism. If you do not get enough sleep, then you'll be tired. If you are tired, then you will not do well on the test. That's given. Conclusion, if you do not get enough sleep, then you will not do well on the test. Does that follow? Validly. Yes, that's valid reasoning using the law of syllogism. 1 says if P then Q is true. 2 says if Q then R is true. Necessarily then, if P then R is true. If P then R. Oops. All right. Moving on then. Draw a valid conclusion from the given statements if possible. State whether your conclusion was drawn using the law of detachment or the law of syllogism. If no valid conclusion could be drawn, write no valid conclusion and explain. Given, if you are 16 years old, then you can apply for a driver's license. Nate is 16 years old. What conclusion can you draw? That Nate can apply for a driver's license. What law did you use? The law of detachment. What does that say? If P, then Q is true. And if P is true, then Q is necessarily true. But this one. If a point is a midpoint, then it divides a segment into two congruent segments. If two segments are congruent, then their measures are equal. M is the midpoint of a segment AB. What do you think? Is there a conclusion that you can draw? There's a lot to look at there, so you might want to pause and think about it. All right. The conclusion you can draw is that AM is equal to MB. The length of segment AM is equal to the length of segment MB. I think you would agree if you look at the picture, that makes perfect sense. By what method of logical reasoning did I get there? Two uses of deduction. I used the law of syllogism, then I used the law of detachment. If a point is a midpoint, then it divides a segment into two congruent segments, if P then Q. If two segments are congruent, then their measures are equal, if Q then R. Well, from there, what conclusion can we necessarily draw? That if P, then R. That's the law of syllogism. Now, we start the law of detachment with if P, then R, which we determined previously. And now we're told M is the midpoint of line segment AB, which is P. So if P, then R, and P are both true, therefore, what can we necessarily conclude? R is also true by the law of detachment. All right, and that's where we get AM equals MB. Folks, you should ask yourself if you can answer these questions. If you can't, you should look back either in the video or in the notes or in the textbook and write down some legitimate answers. What is inductive reasoning? What is deductive reasoning? What are two valid forms of deductive reasoning? State the law of detachment precisely. State the law of syllogism precisely. All right, folks, here's your 20 homework problems. You can do this.